Welcome back to Rishab's Engineering. In today's video, we are solving interesting problem: delete and earn. So stick around till the end. So all right, let's dive in. So we are given with the array nums. So we are given a array, and we have to apply this operation, and we can apply any number of times. So in this operation, it is saying like, suppose if you take any number, suppose it is 4, and you have to delete this number, but you have to add this number in the end, and along with this you have to delete every number which is one less than this 4 and one greater than this 4, and uh, and at the end you have to return the maximum point you can earn by applying above operation. So let me take this example here. So let's say this, let's take this array. So in this array, suppose if I'm taking this 4, so I have to delete this 3. So in this, but I don't have any 5, so this is my one operation. And now in second operation, I only left with 2 in this array. So if I delete this 2, I will take this 2, and this is my answer 6. And if you notice, this is the optimal way to get the maximum points by applying these operations. So let me take second example also. So in this case, if you take this 3, so you have to delete all the numbers which is one less than this 3, and we have to delete all the number which is one greater than this 3, in this case 4, and we have to delete this 3 also. And in the next operation, I have to delete this 3 again, and in last operation, if you delete this 3, we have this 9 as our answer, and this is the maximum point by applying these operations. So I hope you guys understand this problem now. So before jumping to the solution, let me take this example of nums here. So we have values like 22, 333, and 4. In the previous case, we have seen like we have taken the sum of 3, and 9 is our answer, because it is the optimal way to choose to give us the maximum value. But suppose guys, if I add some more numbers in this array, suppose these 3 ones and 1 5, so we are not just taking 3, so we can take this pair, and we can take this pair. Yeah, and we will choose that pair which will give us the maximum value after taking the sum of these values. And at some point in this array, let's say this is first pair, this is second pair, so maybe at this point of time our first pair is giving us the maximum value, right? But we don't know, like if some suppose there are some more values in this array, so maybe our second pair in the end give us the max value, because we are taking sum. To make it short, we can take one bucket array, and we can store the sum for these value for the corresponding indices, because suppose the number can be shuffling here. Suppose 7 could be added here, or 8, something like this. So we have to take the numbers in increasing order, so it will be easy for us. So let's say this is my 0 index, 1 2 3 4 5 6. For 0, we don't have any number in this. For 1, if we take the sum for 3 ones, we have 3. 2, we have 4. For 3, if you add, we have 9. 4 and 5. For 6, we have 0. And let me take one DP array. and this is the one pair we have to check, and this is the second pair. And our first two number will be same in this DP. Now for this 4 we will check second number to the left in this DP. If I add 4 plus 0, if I add 4 plus 0, or I will say is my 3 is max or 4 plus 0 is max? My 4 is max, so I will keep in this DP. And for this 9 we are saying 9 plus 3 is max or 4 is max. So 9 plus 3 is max or 4 is max. 9 plus 3 is 12, so this is 12. Now our 4 plus 4 is max or 12 is max, so we will keep 12 because 4 plus 4 is small. And for 5 we will say 5 plus 12 is max or 12 is max. So 5 plus 12 is or 12 is max. Five plus 12 is 17, and for this last we still have 17, and this is our answer, 17, because this pair give us the max value. This one, second pair in the end. We are doing nothing, but we are keep tracing our max for both the pairs. That's it. And if we talk about time complexity for this approach, so first what we will do, we will traverse through this nums array and we will find our max value, and for that value we are able to create a bucket and DP array for that size. So it should be big of n plus, so we are taking the suppose this is m size array, so we are taking m iteration. It should be big of n plus m, and my space complexity will be big of, so we are having this bucket array and we are having this DP array, so and both having the size of m. You can say this 2m, or it should be approximate to big of m. So this is my space complexity for this solution. So let's try to code this up. We will take one max variable, we'll initialize it with 0, and we will take the max, and we will take one bucket array. It should be of size to this max, but before that we have to increment this max. And we have to add sum for corresponding numbers to its indices. So let's say we have we have to store this 10 bucket, and then we have to take one DP array. It should be of same size to our max, and my first value of DP should be equal to the bucket, and same for second value. And let's traverse through this DP matrix. sorry, dp array, and let's say we have to go till max, and for current value of the dp we should say like we have to take the max of I minus 2, the second value to the left of dp, and we have to take the addition for the current bucket, and we'll say will it be my max or will my previous value in the dp is max. At the end we have to return the last value in the dp. So let's try to run this code. Yes, there is one error. I think it's fine. Yeah, let's try to submit this one. So yeah, if you like this video, please subscribe and don't forget to comment. Thank you guys.